Alright, today we are talking about absolute value functions. We did our examples on the floor here. The reason why this lesson follows what we did yesterday is an absolute value graph can actually be defined as a piecewise graph, saying that if x is negative, we get the opposite. If x is positive, we get what we put in, and if x is 0, we get 0. The vertex is defined as being the corner of the graph. So when we plotted them out on the floor in our activity there, they all look like V's. The point of that V is the vertex. Our general form of our equation looks like this. And we talked a little bit about what each of these does to our graph. A number multiplied in front affects the slope. So the bigger the number there, the steeper the slope will be, which makes it a little bit skinnier. And if I have a fraction number there, that's not as steep, so that's going to open up the V. An H is a shift value horizontally. Something that's inside with the X will shift horizontally, but it goes backwards. Okay? This should actually say positive H because the equation is already subtraction, so that should actually say positive H. But H is a horizontal shift, and it's important to know that the horizontal shift happens backwards of what it looks like it should be. A number added or subtracted outside of the absolute value will be a vertical shift, moving the graph up or down the amount that it says. So to graph these out, what we're going to do is plot our vertex first according to the shifts. Then we're going to use the A value to count out the slope to draw the right-hand side of the V, and they should always be perfectly symmetrical, so then the left hand we can just match up. So what we want to do first is locate where the vertex is going to be. Something added or subtracted inside moves us sideways and backwards. So that plus 2 is actually going to move us to the left 2 spots. The plus 3 outside will move us up 3 spots. So our vertex is going to be at -2, +3. An inside shift is side to side in the backwards direction of what it says. An outside shift is up or down in the direction it says. So that is my vertex. Now I'm going to take the slope value and count out to make the right-hand side of this. So it has a -1 or -1/1 slope. So from this point, I'm going to go to the right, down 1/1, down 1/1, down 1/1. Yes.
How do you do that first point?
The first point comes from the -2 shift for inside and the +3 shift for outside. So inside shift moves side to side backwards the given amount. Outside shift moves up or down the given amount. We count out the slope for the right-hand side, and they should be completely symmetrical, so the left-hand side should exactly match. So I can just match up each of those points over on the other side to get the V of our graph. Learning to shift a function is going to be a recurring theme this year. Every type of function we encounter will have some shifting in it, and the beauty of math is it's very consistent, and so all of our shifting all year is going to follow these same rules. That's why I really want to emphasize our rules today, because we're going to keep on seeing them all year. An inside shift, side to side and backwards. An outside shift, up and down what it says. A number in front is a slope change.
So you always go off first and over?
So for this one, -1 inside moves my graph to the right 1 spot. Inside shift goes sideways in the opposite direction of the sign. So negative is going to go to the right. +1 outside goes up 1. Outside shifts go up 1, up or down what it says.
What if it's a minus?
If it's a minus outside, it would go down. So this one's going to go right 1 and up 1 to make my vertex. The front number gives us our slope of the right-hand side. So from this point up 2/1 to get the right-hand side of the V. The left-hand side should exactly match, so I can just match up those points. So it should be completely symmetrical if I would fold my paper, that those two lines would land right on top of each other. Some of your homework problems will ask you to describe the graph in terms of like wider or narrower. We would say this one is narrower. As it becomes steeper, that V is becoming more narrow. If our slope was not as steep, like a half, then we would say our graph was wider.
So you really only ever do the right side and then just copy the left?
Yep, just count out the slope for the right side and then just copy it over to the left.
Again, on the slope, is it just whatever the number is over 1?
Yep, if it already is a fraction, then we have a rise over or run already. If it's not a fraction, then I just put it over 1 to
So
make it a
like-
fraction.
Like the last problem, it just had the negative sign.
I'm using my computer.
So if it's just a negative sign, that's like a -1 over 1.
So I'm so confused. Like, do you do right to left, right to
We always read a graph from left to right. So we start at our vertex and we count out our slope to make the right-hand side, and then the left-hand side just exactly matches it. Hey guys, focus.
So in the other example, you would go over and then off.
Yeah.
And then, so you always go over and out, like you normally would on
Right.
one.
Right. Yep, slope we count out the same way we would with just a regular linear. So in this one, what is the +2 going to do here?
Over
We're going to put us left 2. Inside shift goes sideways, and inside shift goes opposite of the directed sign. So plus goes over to -2. What's the -3 do?
Goes up.
Down 3. Outside is an up or down shift in the direction of the sign. So since this is a -3, it's going to go down 3. So our vertex is 2 left and 3 down. Then I use the front number to count out slope of the right-hand side. So this one is already a fraction. I don't have to make it a fraction. I have a rise of 1 and a run of 2 to get my right-hand side. The left-hand side should exactly match, so it's going up 1 and back 2. So that when I connect all of those, I get a perfectly symmetrical V graph. If we were asked to describe this one, we would say that it's wider than the original one, because that 1/2 slope makes the lines less steep, so it opens up the shape of the V. Questions? Your last type of problem is coming up with an equation for the graph. We're going to have y equals maybe a number in front, x, maybe a number inside, and maybe a number at the end. Those are the 3 changes that can happen to it. We won't necessarily have all of those, but those are the things that we could have. So, for the number inside, that's defining a side-to-side shift. So is the vertex of this graph moved at all side to side?
No.
No. So that means there's like a +0 in there and you wouldn't even really have to write it. Okay? I just like to have a format that I'm filling in blanks. So if you want to say +0, that's fine. If you want to just not do it at all, that's fine. A number outside defines an up or down movement of the vertex. So what would that be for this one? +2 for up 2. The number in the front defines the slope of the right-hand portion. So from my vertex heading to the right, I go up 1 over 2, so 1/2. For this one, I could have y equals blank, absolute value x blank, blank. Blank inside defines a side to side shift. So did the vertex move it all side to side? No, so +0. Outside defines an up or down movement. So what would that be? -3 because it's downward 3. The number in the front defines the slope from the vertex heading to the right, which should be 2. 2 over 1, or just 2.
So for the number inside the absolute values, that's opposite, like the 0, like positive, negative, negative, positive.
Yeah.
But then when you're going up and down, it's the same.
Exactly. Sideways shifts are backwards, positive, negative, negative, positive. But outside is what it is. I think I have one more here that you don't, but I want to look at this one because something else happens in this one. So focus in for one last example. Sideways shift here. This one has 1.
2.
It moved to the right 2. So how do I put that in the equation? -2 because sideways shifts are backwards. And +1 at the end for up 1. And slope of the right hand portion is 1. Okay? If the V is facing upside down, we should expect to have a negative slope value.
Like 5 minutes. Like,
Oh, I guess I have one more example even here. This one has a negative slope value. So if I were writing up this equation, I've got y equals a negative absolute value because it's facing downward. X sideways shift of +1 since it was left. And downward shift of -2. Questions? So positive should face up, negative should face down. Okay, there's your homework. No extra for honors tonight.
do you want us to move these desks back or